morning. This is Dr. Jesagai Ruben, Professor and Head, Munda Civil Engineering, Rogini College of Engineering and Technology, Kanyakumari. Today in this lecture we will see about the singly reinforced beam section and design problem. In the design of singly reinforced beam, there are three types of problem commonly available. So that first type of problem, to determine the moment of resistance of the given reinforced beam. Second type is to find the stresses in steel and concrete if the moment of resistance is given. Third type is to design a beam for a given conditions. These are the three types of problem commonly available for design of singly reinforced beam. By solving a problem, so first write down all the given values given by the problem. Step number 2 is determine the actual depth of neutral axis, that is n. We have to determine taking a moment about compression zone as well as a tension zone. Finally we get the equation like Bn square by 2 is equal to m into ast into d minus n. This is the formula to determine the depth of actual neutral axis. The step number 3 is the calculation of critical neutral axis. For this we can use this relationship, that is NC is equal to K into D. We have to use the value and determine the NC value by using this formula like sigma CBC divided by NC is equal to sigma ST divided by M divided by D minus NC, where that sigma CBC is a permissible stress in concrete, sigma ST is a stress in steel, M is the modular ratio, D is the depth of the section. This is a formula. Using this formula we have to find out the value of critical neutral axis. So finally we get the value of actual neutral axis as well as the critical neutral axis. If the actual neutral axis is less than critical neutral axis, the section is a under reinforced section. So the under reinforced section, we have to use this formula. There is Munda resistance is equal to sigma st into ast into d minus n by 3. If n is greater than nc, that is actual depth of the critical axis is greater than neutral axis, critical neutral axis, that section is the over reinforced formula. We have to find the moment of resistance by using B into N into sigma CBC into D minus N by 3 divided by 2. So this is the formula to determine the moment of resistance for under reinforced section as well as the over reinforced section. Let us see the problem regarding determination of moment of resistance of the singly reinforced beam. The cross section of the singly reinforced beam 300 mm wide and 500 mm deep to the center of the tension reinforcement, which consists of 4 bars of 16 mm diameter. If the stresses in the concrete and the steel are not exceeded 7 Newton per mm square and 140 Newton per mm square respectively, determine the moment of resistance of the beam. Take the modular ratio is equal to 13.33. So first of all, we already discussed regarding, first we have to write all the given data, like B is given in the problem, that is 300 mm, and depth is given by 500 mm. Total number of bar used in this section is 4 bars of 16 mm. So 4 number of bar, 16 mm diameter bar. By using this, we have to determine the area of steel. So area of steel is equal to total number of bars into pi d square by 4. So 4 into pi d square, that is 16 square divided by 4, that will be is equal to 804.248. So approximately if you have to take the area of steel as 804 mm square. Also that stress in steel, that is sigma st and sigma cbc is given. So sigma cbc is equal to 7 Newton per mm square. Also sigma st is equal to 140 Newton per mm square. The modular ratio m is equal to 13.33. So these are the given data from the problem. First you have to write all the data here. So next step number 1 is step number 1 is to determine the actual depth of neutral axis. As already we know, actual depth of neutral axis b n square by 2 is equal to m into a into d minus n. So in this equation we have to determine the value of n. So b already we know 300 into n square by 2 is equal to 13.33, that is a m value is equal to 13.33. Already we determined the value of AST as 804 into d, that depth of the member, effective depth is given in the problem, the 500 is minus n. From you have to find out the value of n. So n we will get two values, one is 156.63, another value is minus 228.079 mm. So negative value is ignored. So that actual depth of neutral axis n is equal to 156.63 mm. Next we determine the critical depth of neutral axis, that is NC. NC already we know K into D. K how we can calculate by using K is the constant, that is a lever arm constant. So K is equal to m by m plus r is equal to m divided by m plus r, that is sigma st by sigma cbc. We know the value of m, that is 13.33. Also that sigma st is 140 and sigma cbc is 7. From that we determine the value is 0.399. So 0.4. You have to substitute NC is equal to K into D. K is 0.4 into D is 500. That will be equal to 200 mm. So let us compare the neutral axis, that is actual neutral axis value as well as the critical neutral axis value. So n is equal to, already we find the value is 156.63. Critical neutral axis is equal to 200 mm. So the n is less than nc. So the given section is the under reinforced section. Next we determine the moment of resistance. Hence this is a under reinforced section. The moment of resistance value is equal to sigma st into ast into d minus n by 3. So once again, moment of resistance is equal to sigma st into ast into d minus n by 3. As we know all the values, that is sigma st is 140, ast already we determined is 804, d is 500 minus the depth of neutral axis, that is 156.63 divided by 3, will get a value of 50.4 kilonewton meter. So this is the moment of resistance for a given singly reinforced section. Thank you.